So if you're going on to Pre-Calculus 1, Math 141, and if you're going on to Calculus 1, Math 151, it will be extremely important for you to be able to rewrite things in exponential form. And in today's problem set, I've actually given you an example of a rule from calculus that called the power rule that requires things to be written in the form x to a power. So let's get some practice rewriting stuff in that format. Now, this is a good opportunity to go back and review your exponent rules. We're going to be using some common exponent rules, but we're going to be using them backward. Let me give you an example with part A here. Let's rewrite let's rewrite 1 in the form x to some power. Can you think of a power that I could apply to x that would result in 1? Now, the exponent rule that we'll really need to use here is the rule that says that if you raise anything to the power 0, the result is 1. And this question is asking us to take that principle in reverse. 1 could be thought of as x to the power 0. This would be my final answer for this question. Now let's move to part B. Can you think of a power that I could apply to x so that the result would be equal just to x? And here we can use the exponent rule that if you raise anything to the power 1, you just get that thing back. X to the power 1 is equal to x. Rewriting everything in the form x to some power. Let's try it with part C. What do you think? I have 1 over x here, the reciprocal of x. If you were going to rewrite this as x to some power, what power would you put? And remember that negative exponents, x to the power -1, will cause this reciprocal to happen, 1 over a copy of x. What about 1 over x squared? What do you think? Well, again, here, negative exponents are what make fractions happen. This is the same thing as x to the power -2. Actually, let's go to f here. Let's go to f. How would you rewrite the cube root of x in the form x to some power? This is what we were studying today, x to the power 1/3. A fractional exponent is the same thing as a root. Now let's backtrack to part E. What if I gave you the square root? What power is that? Now remember, for the square root, there's a hidden index of 2. So I can think of square root of x as x to the power 1/2, x to the power 1/2. Now let's jump to h. What about for part h? I have x to the power 4 and the 5th root of that. What do you think would happen if I were going to try and rewrite this as x to some power? Recall that the power here is going to be the inside exponent divided by the index, 4 divided by 5, or 4/5. And what about part G? This may be the hardest one. It's hard enough that I think we'll need an intermediate step. If I were going to rewrite the 7th root of x as x to some power, what exponent would I put here? Just like for cube root, 7th root would have an exponent of 1/7. But now, how am I going to deal with this fraction? 1 over x to the power 1/7 fractions, if you want to make a fraction happen, 1 over x to the power 1/7, we do a negative at the exponent level. So anytime you see a fraction, anytime you see a 1, anytime you see a root, these are all powers in disguise. So hopefully this will help you out with the problem set for today.